Hello, everyone, and welcome to the Boundary Systems Resolving Model Regeneration Issues and Best Practices webinar we're going to have today. I'm Sean Ferrier, pardon me, and I'll be your host for this webinar today. We're going to discuss a host of issues surrounding model regeneration and things we can do to improve that and generally prevent problems with it. During the course of the webinar, there will be some discussion slides today. I think I have 3, maybe 4 discussion slides. When we get to the slides that mention webinar discussion, I'd encourage everybody to take screenshots and whatnot of those slides, as there's some basic general good information, best practice kind of stuff I've tried to capture in a few of those slides for our discussion today. After we complete both the discussion parts of the webinar and the presentation parts of the webinar, then we'll have a Q&A session where folks can kind of back and forth with me a little bit regarding the material of the webinar. That being said, it is requested that everybody use the GoToWebinar interface to present questions to me, so we don't have a bunch of people unmuted and background noise, and it just generally causes a bunch of trouble if we try and handle those things through audio. So we do prefer that they be handled through the GoToWebinar interface for asking questions. You are encouraged to ask a question at any time during the webinar. However, at the end of the webinar will be the point at which I will kind of corral all the questions together and speak to them as a whole at the end of the webinar. So with that being said, we're going to go ahead and dive in here today and get started. So today's agenda is going to be to review and demonstrate causes and solutions for regeneration issues and discuss best practice surrounding these things. We're going to have a brief introduction both of the company that is Boundary Systems and myself as the presenter, and our topic overview that we're going to discuss beyond that. Some more detail, if you will, is going to be, we're going to talk about the Creo Regeneration interface. What are your tools and how do you interact with them for dealing with the concept of regeneration inside of Creo? We'll talk about typical causes of regeneration failures in models and assemblies. And we'll talk about best practice for part regeneration and best practice for assembly regeneration. And as I mentioned then, we will have the session regarding Q&A. A little bit about me. I am a technical specialist with Boundary Systems. Been a PTC user since about 2001, PTC certified trainer since 2007. My typical area of expertise is kind of listed there. The manufacturing, Creo NC stuff falls into my wheelhouse. Large assemblies, tool design, surfacing, etc. Those types of things are a big part of my experience set, if you will. A little bit about Boundary Systems. They're obviously a technology leader in this space. Their partners include PTC, obviously, eTraj, and other technology companies. They're one of the 16 fastest growing private companies in the greater Cleveland area. They are a part of the PDSVISION group of global companies. The capabilities include product life cycle management, data management, CAD design and consulting, simulation products, and product development specifically. Boundary Systems has been awarded for their work, some industry awards, and major accreditations that have been bestowed to Boundary Systems are shown here. Some solution providers that Boundary Systems works with are shown on this slide. Obviously, PTC partner, that'll be the material we're speaking to today, as well as systems like eTraj, Keyshot, Moldex 3D, ZWCAD, etc. Basically, your technology needs have a partner and a solution inside of Boundary Systems. Okay, so with that being said, we're going to dive into the webinar discussion. Okay, so a little bit about regeneration and Creo and regeneration and when there are problems with regeneration, etc. Some time back, circa the Creo release, in and around that time frame, PTC made significant changes to the regeneration interface. Those of us that have vintage with the product, if you will, remember our beloved resolve mode from back in the day, which was arguably, while very good for folks to be forced to fix problems immediately right now, it was not arguably everybody's favorite interface to do it with. So the evolution of the resolve theory inside of Creo has been a little bit ongoing in the more, shall we say, recent, if you will, time frame. We are no longer obligated to use resolve mode to solve regeneration issues. We can use what I would call an inline or no resolve mode solution workflow. And that's what we'll primarily be focusing on today, as in my experience of traveling around the country for over the last decade and helping folks, it does seem like the greater share of the Creo user base has adopted the new form of regeneration and resolution, if you will, and let go, if you will, the old resolve mode stuff. So we'll be working with it in the newer forms today and not with resolve mode techniques specifically, if you will. We have a couple of core functional interface work areas to work with issues related to regeneration. They are respectfully the Regeneration Manager and the Notification Center. They have a little bit of overlap in what they do, but they are arguably both key in your work of understanding where your problems may lie in a regeneration problem. The Regeneration Manager specifically allows for controlling whether or not you're going to see the old resolve mode. Many of these things, it also goes without saying, that I'm speaking to during the course of the webinar today, and I will speak to this specifically later, but arguably many of these things are governable by config.pro and config.sup implications for your local work site. So resolve mode failure handling can be otherwise switched on and off through the Regeneration Manager. This also controls the creation of the backup model for regeneration. Insisting on your system creating the backup model as a part of the regen cycle does have a performance impact. It is not free. It may in fact be more durable, but it again is not a free pass in terms of expediting the regeneration cycle. That is a decision that must be weighed locally based on the work that folks do as to whether or not it is justified to mandate the creation of the backup model as a part of the regen cycle. How mass properties are being, pseudo-handled, if you will, during the regeneration cycle, control for that is also accessible through the Regeneration Manager. Obviously, in the case of assemblies more so than in part mode, the implications of calculating mass properties as a part of the continuous regeneration cycle can have enormous implications on the speed of your regeneration cycle based on the geometry and volumetric size of the parts in question in the assembly, and not to not also include the part count also being very important there as well. The Notification Center. This allows you to access different options about the Notification Center itself. It allows you to isolate failed features and models in terms of seeing only what is failing, as opposed to seeing virtually the entire assembly in the context of the Regeneration Manager. Failure cause information, additional failure cause information is presented here in the form of a tooltip. We will see this during, the demonstration part of our work today. Accessing editing tools for reference and feature definition is also available to you here inside of the Notification Center. You can also locate the failed feature or model in the model tree using this interface. So the Notification Center is probably the first and foremost line of defense that you'll interact with in the context of a regeneration problem. The Regeneration Manager arguably has a lot of implications about the speed of your regeneration cycle based on, what efforts you put into it with respect to both the backup model creation and the mass property calculation. I will give you a little bit of a tip today, if you will, on some of how I deal with the mass property calculation handling on my own. I have what is arguably maybe a little bit of a unique way of dealing with that issue as opposed to regenerating mass properties in line at all times and subsequently then paying the price for that calculation in the regeneration cycle. Okay, so I'll mention that stuff as we go through the presentation parts of the webinar today, and we are actually looking at the models. Typical causes of regeneration failures. I could have kept everybody for the remainder of the day listing all of the different things that break a model, clearly. There are enormous vectors under which that model problems come. What I've tried to do here is capture what I see as being the most typical cause-effect relationships that seem to break things down in a general sense. Things can be very complex in this way because clients may or may not be using wind chill or search path definitions in absence of wind chill, and a host of other things like that can come into play that do involve, typical causes for regeneration failure. So regeneration issues can be site-specific is somewhat the moral of the story here because of the nature of the work and the Creo environment that is being configured and deployed as to whether or not that environment includes or does not include wind chill when we speak to larger assemblies specifically. Part regeneration failures, feature creation is of an invalid result. So a lot of times we can go make something that is, or convince Creo to try to make something that is subsequently geometrically invalid. When we get to a place where Creo is creating something that is geometrically invalid, that's going to be a scenario where, Creo may show you a preview, but it's not really going to make the feature. When you say okay and click your green check marks, it basically blows up and creates a failed feature at that time. Now, as we're going to see here in the webinar today, I'm going to demonstrate some explicit later failures where a perfectly good feature subsequently fails later because of changes to the model. And those are also implications that need to be considered because features affect other features by parent-child relationship. And as we'll speak to here in a second, accuracy also comes into play. So we have feature references missing is also a potential problem here. So when we use something as a reference, we have the expectation that it's going to hang around for a while. When those things are subsequently deleted or eliminated by modeling change, sometimes we might use an edge, and because we make subsequent change to the model, the definition of that edge is dropped. It's no longer a part of a surface boundary or something to that effect. Well, that edge was still a reference for a sketch projection or something. It's going to fail because it is no longer there. And in every case where something we referenced goes missing to Creo, we will create a failure for that. Accuracy changes due to using relative accuracy. Relative accuracy can be very tricky to work with, and it can be very impactful as it relates to the model regeneration time cycle and the stability of that model regeneration cycle. And understanding what's actually happening with relative accuracy and how this can and does affect your modeling is important. So I have attempted to, capture, and we will see in the demonstration part of this, some of the pitfalls related to implications of relative accuracy in modeling today. So be aware of that. That is a thing that does in fact cause an enormous amount of part failures, quite frankly, because they can creep up on you in an after-the-fact sense, as we'll see today. So the kind of moral of the story being is that large models having small features are just not a good fit for relative accuracy. Large model and small feature is a scalar relationship. A large model could be something that is no more than a 1-inch square cube in the context of a feature size being in tenths English of creation. By the same token, an object that is 20 feet long in Creo has a small feature size that has a much higher threshold than English tenths. It could be up 10 thousandths. You could be up to a 0.01 minimum feature size on extremely larger objects. This is a relationship of scale, and I will attempt to show that today. And it is important because features that you create can be fine right now at the time of creation, and subsequent follow-up modeling changes can break that feature based on nothing else other than accuracy when we are, in fact, using relative accuracy. Assembly regeneration failures come, and again, just like parts, just an infinite number of potential vectors. But some typical causes are Creo is unable to locate a required assembly component. Usually somebody is working outside of Windchill in this case and using Windows to rename stuff or moving files and folders on the physical disk that Creo has subsequently been previously assigned to go find things in. Basically, we're going to get a regeneration failure in assembly mode if we can't go find all of the stuff. And finding all of the stuff comes from either the working directory, search paths, or effectively Windchill at the end of the day. So, accuracy conflict with assembly features. The same accuracy implications that I mentioned in part mode exist in your assembly as well. Assemblies have a defined accuracy also, and that accuracy can in fact be in play when we do certain assembly-based operations. Those accuracy changes that are occurring during the use of relative accuracy can have notable implications with regard to this. Huge. So things like cut, merge, etc., those features, those types of features in assembly can be volatile in the context of relative accuracy as well, because of the same reasons I aforementioned with respect to parts. Changes in sizes will result in changes of base footprint size can ultimately result in a change in overall accuracy, which can create conditions where parts don't have matched accuracy, which causes problems with assembly features and things to that effect. So it is another pitfall to watch out for. We do not get a free pass as it relates to assemblies and accuracy if we are in fact using assembly features. Assembly component placement references have become invalid due to feature level changes. So if I put a bolt in a hole on a part and I subsequently decide later on that the part doesn't have the hole, the bolt's placement is now a problem. This is pretty boilerplate stuff, but it does in fact need to be mentioned because it speaks to the concept of how we work through sharing information and, how the system is regenerating and what is expected to be there when it does. Missing feature references for a component placement or feature creation. So oftentimes we might go change part 1 in the assembly and it's got some stuff in it that we used in part 3. Well, if we go change part 1 in some way that those things are no longer there, as we previously mentioned, under all circumstances when a declared reference becomes unavailable to Creo, it will regen fail. That's expected. So those are things that will typically cause a regeneration failure. Any conditions that cause regeneration failures obviously increase the time footprint for the regeneration cycle. So, okay. Improving part regeneration time and model stability. So, what are some basic thoughts about making this stuff better at the end of the day? Round features at the end of the model tree. I'm a big advocate of this. The cosmetic stuff should all be piled up on the bottom and easily grouped together so that insert mode or direct suppression can be applied to all of that cosmetic feature set and subsequently taken out of the primary regen cycle for the purpose of most modeling operations. It is best practice, and it is very much something that most folks should not have a conflict in terms of integrating into their workflow, because best practice does dictate that cosmetic features aren't going to have child features anyway. If the stuff's not going to have child features anyway, it should be piled on the end of the model tree, and there's no harm, no foul in suppressing it temporarily while you're doing bigger level modeling options upstream and enjoy the benefit of an increased and improved, regeneration cycle. Less time to regen because we're not building out all those cosmetic features while we're in there doing heavy lifting in the design or something to that effect. Avoid using the auto round feature on complex models. The auto round feature is awesome and it is notably elegant for what it does, but it is arguably a heavy lift feature. It does a lot. It's got to have an entire model scan in it, and it does a scan, and then it goes back and it does an elimination based on edges that you have declared will or will not be included explicitly, and then it goes about the process of rounding out all that stuff. I know it's not necessarily good news for somebody on the webinar that's been getting good value out of it that way. But I will tell you that if you were to go in and end of cycle modeling at the end of the tree, do that same rounding work with conventional rounding functionality from PTC, you will have a faster regenerating model at the end of the day. Now, a lot of people use the auto round feature and then dissolve that into individual rounds to expedite that process. I cannot take issue with that. There is arguably, in my opinion, nothing wrong with taking that workflow. But leaving an auto round in a very complex model can really just put a burden on that model's regen cycle that arguably may or may not be necessary. Your mileage may vary, and local engineers are the best to make that, declaration as to whether or not auto round is a good fit. I don't wish to make the tool seem like the wrong answer. I just wish to make everybody understand that it does come with a price to pay. So, avoid edge rounds where possible. Use surface rounds. These are going to be more robust and arguably in many cases regenerate a little bit faster. Avoid allowing rounds to have child features. The only exception to that is typically upstream shelling operations. Sometimes we do need to get rounds in there early in the model tree prior to a shell operation, but beyond that, it's most typically not necessary. Meaningless features that don't regenerate something for nothing, basically. I see a lot of this in the model review I do, especially as the model complexity increases. Things get just left laying around in there, at the end of the day. Every single feature that is in your model, you do pay a price to regenerate that feature, full stop. Maybe it's insignificant and it's nothing because it's a datum plane. Maybe it's a whole bunch of stuff, time and play, because it was a surface that was complex. But then you subsequently didn't use it. Get rid of that stuff. Models should not regenerate things that are not necessary. Some other thing, some examples of meaningless features. Cuts that don't intersect the model. Creo will inform you when you do this, but it comes up in the message bar where we've been trained by Microsoft to ignore. So in everybody's defense, we don't always catch that message down there that said, hey, you missed the model with this cut. Extrudes that fill pre-existing holes and cuts. There are arguably much better techniques in the system now to be handling these issues. And arguably, that's kind of falling into the realm of what a lot of folks would consider to call a hack in terms of modeling. Datum features without children, another one of those that just doesn't make sense at the end of the day. Don't regen these things. All you can do is set an object up for failure that is serving you no purpose. It serves nothing to model stability or regeneration time. Accuracy. Use accuracy settings that are appropriate for the design, and avoid using relative accuracy when the design requires small features on larger parts. Improving assembly regeneration time and stability. Use a skeleton or driving model when possible to share information. We're going to see when we talk about CRC errors here very shortly why that's a really big deal. Use the default constraint for the first assembly component and any components that are designed in assembly context thereafter. Be sure information is correctly shared across models. We're going to talk about that big time here when we jump into the demonstration part, because that's a big part of making the regeneration cycle insufferable at the end of the day is a regeneration cycle that includes CRC errors. PTC will regen it, but they'll be grumpy, or PDC will be grumpy about that from beginning to end, and it will take more time to do it. So we want to resolve these CRC errors right away when they crop up. The same can be said for accuracy errors. If you are seeing ACC errors and messages for ACC errors in your message line, we need to go fix that too. That's definitely not helping your regeneration cycle. Use simplified representation to reduce complexity when possible. Just use the automatic rep in the more recent versions of Creo, etc. Those things will help improve your regeneration cycle time enormously. Make sure that the config.pro settings are appropriate for the work site. There are basically 4 big impact groups of config.pro settings that will affect model retrievals and regenerations inside of a Creo work site. Family table retrieval settings can have enormous impacts on how that's handled. And I'll show you how to go find these things in your config.pro today. Regeneration, there are settings specific to how regeneration is handled. There are settings for component retrieval and subsequently mass property calculation as well. Those big 4 items have probably not exclusive, but the largest impact on overall regeneration cycle in a day-to-day business sense for all users of a given Creo worksite. Accuracy, again, make sure it's appropriate for the design and worksite. Avoid relative accuracy when using assembly features, hole, cut, merge, inherit, etc., because they can become very problematic with mismatched accuracy and large distinctions between model size. Okay? So that covers the discussion part of this. This is my contact information and the information for Boundary and our sales team. Once we complete the demonstration part here and we get back to Q&A, I will be putting this information back on the screen for everybody to screenshot or get information from. Okay, so with that being said, let's go ahead and have a look at Creo. So what we've got here is a Creo model, basically, and we're going to break it, and we're going to look at some regen stuff, and we're going to be looking at Creo assembly stuff. We're going to look at a host of things, okay? So, all right, first things first, let's look at the Regeneration Manager, okay? So our Regenerate tab and our Regeneration Manager up here at the top allows us to access the Regeneration Manager, okay? And it comes up, tells me I don't have any modified features because I haven't done anything yet. Now, this allows me to control through preferences, create the backup model that we mentioned, mass property handling, how those things are going to be done, etc. Okay, so as I mentioned, this is your Regeneration Manager. It will give you information about the entire assembly and its status with respect to regeneration on the cycle of regeneration. If there are problems, there's more information here than in a case like what we have now where we don't have any problems. But this is subsequently your Regeneration Manager. Now let's have a look at the Notification Center. So to do this, first thing I'm going to do is come over here and break the model. So we're going to go ahead and delete this axis that is called crank, which is subsequently holding down hole ID 331 today. And we're going to go ahead and delete the axis, but we're going to suspend the hole because that will break the model. So we go ahead and do that. And now we see the context of the newer, more elegant resolve mode, as I mentioned. The object is turned red in the tree. It's red on the model. And we have notifications now. Earlier versions of Creo used a traffic light type scenario down here where we see the little notification flag in my message bar. So in this case, I can simply click on the Regeneration Failed entry here, and that will activate the Notification Center for me, okay? So now we see in the Notification Center that we say, hey, this whole ID is the failed object. If I hover over this, I get a nice tooltip telling me, hey, this whole failed regeneration, it's not up to date. It could not place the feature to create it, and it has feature references missing. So there's my extended information about what Creo perceives to be my problem here. Okay, so the notification center is incredibly important to you for that, because it also focuses exclusively on the failed things as opposed to looking at the totality of everything, which the Regeneration Manager subsequently does. You have notification center options now in Creo, and we'll look at this briefly. I'm not going to spend an enormous amount of time kind of weeding through these, but you can access these both through the File Options menu as well as the Notification Center, as I've just shown. Now, this governs how Creo will respond to all these different conditions that Creo says, hey, these can be some type of problem. How do you want to handle this? Do you want errors? Do you want warnings? Do you want nothing? What do you want to do here? So both on a global sense for complete work sites and on a user case basis, if you would, these settings can be manipulated to be more appropriate for the user and the work site. Okay, so let me get the notification center back up here. We also have some basic tree information for the notification center, and you'll see that if I click the object in question inside the notification center, it subsequently allows me to short circuit right to edit definition, edit references, the reference viewer, and the Regeneration Manager right from the notification center. Then to utilize those tools to fix problems, as we might in this case. So in this case, I might subsequently just click Edit Definition right here from the Regen Manager. We see that we've got a scenario where this axis is missing. The user might subsequently come and create the new axis to replace the missing one, and then subsequently select that axis to be their missing, or to be the new reference for the feature here, and then subsequently complete that process. Now I have fixed the feature and exited the notification center simultaneously. Okay, so that's just a little bit of basic, looking at the Regen Manager, looking at the notification center, understanding some of the tools that are available to you for working with that stuff. So now we're going to look at a different model. So now we're going to go ahead and open up a part that I've also created for some discussion. Okay, so in this context, I'm going to go ahead and unhide this surface that we have over here as far as that deal goes. So we have a surface over here that we went and created. Now, the surface is based on just some boundary blend, and we see what it does, and everything is valid. Now, we see here that if I were to subsequently make changes to this, I can subsequently break this surface at the end of the day. So let's say I put a thousandths of offset or something in here. Whoops, that actually worked. Maybe I need a 0 offset for that. The surface could be made to be intersecting. Here we go. So now the surface is failing, and here we can select our notification center and go to the boundary blend. Okay, and it says, hey, we failed regeneration. Feature geometry cannot be restored. You can make changes to a pre-existing feature that did regenerate, and it will subsequently then fail. Surfaces are really good for those types of problems. I'm going to go ahead and suppress this for the remainder of discussion on this part. Just be aware of that I can make a modeling change that's going to subsequently break something down. The same can be said for, as we mentioned just a minute ago, missing references. If I delete a reference, it's gone, doesn't know how to do it, and now we're not going to regen that. Now, another thing that this model exhibits intentionally today is a couple of things specifically. First off, we have this A2 axis right here, as you see, and we also have this datum 1. Now, the cool kids arguably periodically check things by selecting objects in the tree, right-clicking, and say Information Reference Viewer. The reason we're doing that is to pull up the reference viewer and see if we got anything over here on the right-hand side. This is a perfect example of a feature that has no place in this model. It has no children. It's a datum. I'm paying the price to regen this thing, and it offers me nothing. It should subsequently immediately be deleted from the model, or it should find its purpose, and it should have a child. Now, the same can be said for cuts that don't intersect the model. So when I regen this model, if I make a change to it, okay, and let me just edit the definition of this cut over here. We'll change it to some other number. And then you see right here, I'm going to get a warning in the message line. It possibly scrolled back past, depending on how many lines you're showing. But Creo does come up and tell me, hey, this cut missed the model here. This is another good example of something that's valid that shouldn't be in the model because it's going to make regeneration take longer than necessary. Just because the feature doesn't intersect anything doesn't mean it's free in terms of regeneration time. It's absolutely not free because Creo is out there building it and basically validating that it in fact does not intersect anything. And you are in fact paying a price for that reality in your regen cycle. So make note, these things need to be taken out of context, okay? So cuts outside the model, things to that effect, not good for the regeneration cycle. So now we're going to have a look at another broken model today. Okay, so we're going to pull up a fail assembly here, and we're going to regen this. And I'll pull up my message line up here so we can see more of this, so we can kind of see what's going on. Now, before I get involved in speaking to the CRC error that this model has, it has a CRC error. I'm going to explain why it does. We're going to go fix it, and we're going to talk about what fixes it, etc., all that kind of stuff. So bear with me. But before we do that, I promised that I would speak to some implications related to accuracy. So let's do that. So here we have a situation, I'll put this down just a little bit more there. So here we have a situation where I have this brick over here, okay? And it's called the accuracy fail part. Now, on this accuracy fail part, we have, and I'm going to zoom in here so you can see, I have a very shallow cut on the corner of this part. The cut is subsequently, and I will activate this object here so we can see the dimensional information from it. The cut is subsequently only 1/1000th English of depth, and the object itself is basically a 1-inch cube, okay? Now, here's the thing. This part's in relative accuracy. It's basically in the standard PTC default accuracy condition, which is relative accuracy 0.0012. That number being unit neutral in relative accuracy because it is in fact a scale value and not a measurement. So that's neither here nor there. What matters is watch what happens here. So there's two things in play. I have this cut on the model, and I've subsequently used this accuracy fail part to make an assembly cut, as you can see highlighted here, inside of my A part. All right? Now, if I subsequently make dimensional change to this part, and I'm just going to take it from 1 inch to 6 inches, and I'm going to regen that. And as soon as I do, as soon as I regenerate that, you'll notice that my cut that was 1/1000 deep immediately fails. The hole in the part doesn't fail. The extrude doesn't fail, but that cut fails because it no longer plays in the relative accuracy range scope now. So that's a thing. It also subsequently failed my cutout in the assembly, essentially, because as you see here, the cutout in the assembly is not subsequently updating as we would expect. We would expect that cutout to be a cut through the model now, and it's in fact not that. If we open up the model, we see the cutout. It's being noted that it's out of date, but that's in and of itself a problem because it's not current with the model change that has occurred. Accuracy can definitely cause these problems, so it is something to be conscious of when you're subsequently working on these things. If you're using relative accuracy, it can be failing your stuff, and it can make no sense at all about why. If we subsequently go look at extrude, at this failed extrude now, and we pull up our tooltip, hey, this failed regeneration feature geometry cannot be restored. It does not come up and tell you that this problem was about accuracy. I do recognize that that is unfortunate, but it is what it is. But the exact problem that we have here is related to an accuracy relationship. It is what has caused these things to fail subsequently. So I'm going to go ahead and put that back to a subsequently regenerable number now that that's been shown. Now, here we have a circular reference, okay? So I pull this up and we see, hey, this fail assembly has a circular reference. I'm also being given that information in the message line. Now, what is a circular reference? Well, what happens is a CRC file is created in the working directory and subsequently your workspace if using Windchill. This defines the loop theory that PTC is trying to solve here for figuring this thing out. Now, this is very cryptic, and I recognize that. But some things to note about figuring this out and subsequently what's going on here is one of the most helpful things to do is to subsequently make sure you get some tree columns turned on. If you find yourself in this place, adding the feature number and the feature ID to your tree display using your tree column settings is going to prove invaluable for you in terms of being able to determine what they're talking about with respect to component IDs and respectfully feature IDs. But I'm going to speak this out in very simple layman's terms and then show you what this looks like in the correct theory. So why we're having this CRC error works like this, and this is enormously typical. And if you want your regeneration cycle to be slow and problematic, just go do this thing. And that is tell this part here that it's subsequently going to go get a piece of information from one of these parts down here. And that's essentially what's causing our stupid problem here is because I'm saying inside of part A, I'm creating this hole right here. And if we were to subsequently pull the reference viewer on that, we see that, that hole is subsequently parented by an axis in the C part and extrude to inside of the obvious part that it is. But this is the thing right here that's a real problem. This axis in part C2. Now, when part A is being regenerated, because these things are regenerated in the order in which they appear, when part A is being regenerated, how does it know anything about part C? It's not there yet. Just because Creo lets me activate this part and pick this hole or this axis on this later occurring model, just because it lets me do that doesn't mean that's the right way to do this, because it's ultimately not. Information should be shared down the model tree in a direct sense. It should not be shared, haphazardly or attempted to be shared back up the model tree. This relationship of defining this hole in this component, the C part, and then trying to pass it back up to a part farther upstream, and the hole's holding up the B part and all of this other stuff, this is essentially what creates that loop, because PTC is saying, hey, when I'm regenerating this A part, I don't know anything specifically about the C part. So information from it is questionable. This is what creates your CRC error, and solving this is looking into this right here. And it says, hey, this feature number 11 in model A part refers to some stuff down here. Well, okay, what that's essentially communicating to me is this whole one here, which is the feature that it spoke to, that's a problem, because you're getting that definition from a subsequent later part. So you're going to have to figure out how you're going to get this information into part A, or how you're going to define this whole absent trying to get it up out of part C in this literal way that it's been done. This is what creates your CRC errors at the end of the day, because you are trying to get information down from something, and you may actually be holding that information up with the parent. In this case, part C can't exist because it's on top of a stack of these parts that are built up on top of part A. So even from a positional sense, where the heck part C is difficult to conceive when we have things going on from part, if part A is not there. So how is part A then going to go get information from part C when part C requires part A to exist? These are the concepts that break down regeneration cycles and cause enormous frustration and pain. And that's why when these CRC errors are coming up, you need to go fix this. You need to deal with it. It's telling you where your core problem is. Feature number 11 inside of Model A is where the big ticket breakdown is occurring here in this context. Now, what does this look like in the sense where it's not broken? How would we go about resolving this at the end of the day? So I'm going to go ahead and put this assembly away for a second, and we're going to go pull up an assembly here that speaks to the way that it's really done. Now, this might be done with a map, with some type of mapping to a standard Creo part, which would be a driving model, or what is most typical is that the Creo Advanced Assembly skeleton model functionality is what is used, and that's what I'm doing here today to show the concept. Now, on the face of it, we recognize that part C must share something to part A to declare the position of this hole in part A. Okay, all is not lost. We said that we couldn't do it the way that it was done in that previous assembly where we just went and picked on that stuff in part C and we activated that. So what does it really look like? How is it really supposed to be? It works like this. We have a skeleton or some type of, driving model, okay, core model, whatever you want to call it. And we have part C. And here's the hole, here is the hole in part C that we need the information from. So what we subsequently do is create a published geometry, and I am showing the more formal sense here. Quick sidebar. I'm showing this in a more formal sense. There are other, ways to approach this. Not everybody uses the full formal copy publish, but Sean's kind of showing the textbook theory today. Okay, so we come into our part C and we publish those surfaces of that hole to a published geometry feature that you can subsequently see here. They're created from the model intent group, okay? So we create a published geometry feature inside of part C. What we subsequently then do is create a copy geometry feature inside of, and this is a copy geom feature that references that specific published geometry in part C. And we place that copy geom feature inside of our skeleton or in control model, if you will. All right, so we have a copy up there. So then we utilize that copy geometry to create the reference we need if necessary. In this case, I don't really want the surface. I need to hang a hole location. That's all I'm out to do. So all I'm going to do is create an axis off of that that copy geometry, and then inside the skeleton, I'm going to publish, again, creating another published geometry that is that whole axis. What I then do is copy geom that publish down into my part A. Part A is now looking at a published geometry feature inside of the skeleton. It is not looking at the direct reference existing on the model in part C. Okay? So this is how we would subsequently govern that information flow and get it to a situation where now we have a scenario where we're sharing that information, we're sharing it properly, and I can regenerate this any number of times. There is no flag of caution. There is no CRC error. Everybody's happy. And I am sharing the information from part C to part A and the proper structural theory. Now, for those that don't have the advanced assembly functionality from PTC, you first off have my condolences. Second, the same technique can be done in a fully disciplined way. If your group has the discipline, this can be emulated with what was subsequently referred to previously as driver model or control model, and that would just become another PRT in the tree as opposed to enjoying the functionality of skeleton model, if you will. Okay? Obviously, renaming these items on the disk can cause a problem. If I were to subsequently go into Windows and rename one of these objects, when I attempt to retrieve this assembly, it will break. I will not be able to retrieve those objects. It will fail. Okay? You can utilize, as I mentioned, simplified representation was one of the things I mentioned. You can utilize simplified representation to improve the regeneration cycle further beyond making sure that these issues are not creeping into your assemblies. CRC errors, meaningless features, improper configuration.pro settings. When all of those things do not exist in the work site, then we can further start utilizing things like the automatic representation and user-defined representation inside of Creo assemblies in order to further improve the regeneration workflow cycle. Okay, so a little bit about finding config.pro settings that are important to you. When you go to your configuration editor, and we access that by File, Options, Configuration Editor, down here, we see we have a Find button for the Configuration Editor category. We can select our Find button and then type in something. So let's say I need to know about family table regeneration as it relates to things that would be very important to me for regeneration cycle for family table objects. Now, in this case, I might start by saying generic. And I always say search the descriptions, and I say find now. And I'm going to get a pretty consolidated list of things that are related to the generic instance of a family table. And as we see, there are issues here. Retrieve instance dependencies. Select instance on retrieval. Determines whether or not revision change numbers increased, etc. You have implications for these things as it relates to the regeneration cycle. Instance would be another word in terms of looking for family table stuff that might be affecting your regeneration cycle as far as that deal goes. Retrieval, if I were to type in retrieval and go search for that, I can also get information about retrieval as it relates to the regen cycle. These things are going to be site specific. I can't give you a generic set of settings and say do this because everybody's environment is different. What I can say is that it's enormously important that everybody at a CAD administrator or some level takes the time to get in there and search those config options, either based on family tables or components or whatever it may be that potentially affect your regen cycle, and make sure that those things are appropriately being set for your work site. Okay? Now, that being said, we've kind of covered a lot of ground and looked at a lot of different things in assemblies and parts in terms of regeneration. What are CRC errors? What do they tell us? How do we subsequently work to avoid them? CRC errors are an enormous impact on the regeneration cycle. Having CRC errors in there is going to make regen slow. It's going to make it require multiple regens for PTC to solve it. It's just going to not be a happy place for Creo users. So at the end of the day, it's enormously important that you keep track of this stuff in terms of what your settings are, what you're going to do for simp reps, how you're managing the regen cycle as a whole, using best practices, using good design discipline. All of these things speak to having a happy life when you click regen and not having problems creep into your models that cause delays and problems with respect to the regeneration cycle. So I'm going to go ahead and put this one away now. I'm going to go ahead and go back to the broken example that I can subsequently, use to open up or speak to problems or questions if somebody has some. I'm going to go ahead and bring back my contact information here, and I will keep that assembly open for folks and question and answer. And I encourage everybody to visit the Boundary Systems YouTube channel. You're going to find at some point not only this webinar, but an enormous depth of webinars that have been done by the company to help folks with a variety of topics. There's a ton of very good content up there now. I encourage people to go look at that. You might find a very similar webinar to this done by one of my colleagues, somebody like myself, and get another perspective that includes additional information that I might not have covered today. So with that, I am keeping the floor open for our remainder here. I'll stay a few extra minutes, maybe 5 or 10 extra minutes here today, get close to maybe quarter till or something to that effect, and to wait and see if we can collect some questions. So if anybody has questions, by all means, go ahead and start forwarding those questions into me using the GoToMeeting question interface, and I will work to speak to those questions as quickly and effectively as I can. Okay, question came in regarding regeneration and fatal errors. Okay, typically, and I cannot guarantee this to be the case here, but historically, one of the big drivers of that, when you're getting fatal on regen, it doesn't have the feel, but the vast majority in my experience of those are often related to a graphics issue. Graphics drivers that aren't playing nice, a graphics card or graphics subsystem inside of Creo that does not play nice. Those types of things have been a very big driver of fatal error tied to the backside of a regeneration, meaning if we regenerate and then it kind of acts like it's doing it all, and then at the point at which I expect it to be done and I move on is the point at which it blows up and I get a trace back error. We usually start with graphics troubleshooting there, and arguably the first line of defense is I think the config.pro setting still applies. There used to be like a WinGDI 32 or something like that setting that we would deploy that subsequently turns off OpenGL. It makes the graphics look kind of crappy. I acknowledge that. But it does turn off OpenGL, and that allows us to more or less quickly confirm as to whether or not that is a part of the issue. So I would encourage anybody that's maybe having volatility at the end of the regen cycle to look into those possibilities as potentially being part of it. It doesn't feel like it. It feels like it's a modeling thing, I know, but historical norms for those of us on the tech side have often, not always, but most often shown those to be graphics related. Okay. Hold on a second. I need to expand question. Bear with me, folks. Some of the questions you guys are punching in are awesome, and they are exceeding the little space that GoToMeeting is showing it to me in. So bear with me while I get that opened up and I can see the entire question here. Okay. Question related to the CRC error and which component has the issue. Okay, so let's pull the CRC statement back up again and have a look at this. As I explained it in the context of the assembly, the core problem here is that part C in my assembly was used to declare something explicitly in part A. Part C occurs later in the regeneration cycle. These things are regenerated in the very order you see them occur in the tree. So part A is regenerated first, before part C. Now, we're using something from part C. So that's kind of broken on the face of it. This is telling me where this is starting upstream is what I explained to people. Feature number 12, component 1513 ID in model fail assembly refers to feature number 11, this whole ID in model A, okay, in model A part. This lot of times in these CRC feedbacks. This says component, component, component. This is a feature. That's a good place to start looking for your problem, is on the feature level, not the component, okay? Which component has it? It's telling you that right here. It's saying this feature in this model. This is where I encourage people to get started when they start reading and evaluating CRC errors, okay? Config.pro setting, prevent instances from regenerating. Okay, question related to config.pro to prevent instances from regenerating when working with the generic, okay? There are config.pro settings related to this, and how instances and generics are handled in terms of regeneration. Windchill, if you are using Windchill and family tables, there are also implications here. Obviously, the two family table rules that come to mind that are always worth iterating when you're using Windchill and family tables is we never delete instances from a family table that we're managing in the Windchill environment, and we don't use nested family tables inside of Windchill environments unless we're willing to concede the problems that might create. So those two things, related to Windchill and family tables specifically notwithstanding, there are definitely settings that control whether or not and how both generics and instances are regenerated during the course of the regen cycle. They may apply to you, they may not, based on how your work site is configured. So it's important to discuss that those things exist with your CAD administrator, and then sit down and have a real evaluation of, do those settings make sense? Are they being used in the correct way inside of your work site environment for the need at hand? Because at the end of the day, you may be paying an enormous price for regenerating family tables that you not need to, and arguably you may be paying that price because you need to. So it becomes a very worksite specific thing when we start speaking to family table, generic, instance, regeneration implication. Who's working on the tables? Are these static libraries? Is the table dynamic? Are these objects potentially changing? All of these things come into play, and they must be considered when we speak to the context of declaring the family table config.pro or family table related config.pro settings in the context of regeneration. So there is arguably a topic and a thing in and of itself there. That is something having some fair depth in and of itself, and again is arguably, in my experience, very worksite specific as to how that environment actually must work or look and work. Okay, so good stuff, good questions. I love it when I'm getting questions. I'll hang out for another few minutes if I keep getting questions. If we don't keep getting questions, then we'll probably wrap up the webinar and let everybody go on about their day. But now is a really good time to continue to punch in any questions that you might have. I'm going to punch the contact information back up on the screen for myself and arguably the company, of course, and the YouTube channel mentioned. We'll keep this up on the screen while I sit here for a few minutes. At least I'll give a few more minutes here to see if somebody's taking the time to punch in some questions to me. And if we can catch some more questions, then I will obviously speak to those and we'll take care of that before we wrap up. But if we go a few more minutes here and I don't get any questions, unfortunately, or maybe fortunately, if you're already tired of the webinar, we'll go ahead and wrap things up for the day. So again, I am enormously grateful for everybody's time and participation today. I hope people found it helpful and informative, and I am ready to take additional questions if some folks can punch that stuff out to me. Okay. Question. Thank you for it. What version of Creo am I using today? So today's webinar was done with Creo Parametric 6010. And on that note, and that is a very good question, and I'm very thankful for it, and I should have done a better follow-up to it. That being said, pretty much everything I spoke to in context today is typical from everything I think about Creo 2 onwards as it relates to regeneration. Now, that being said, Sean's getting a little long in the tooth in terms of vintage, but what's left of my memory tells me that this automatic representation stuff that I spoke to, that did not come about until right around Creo 4 and later, if I remember. Maybe Creo 3, somewhere in that range. But automatic rep, I don't believe, goes all the way back to the initial Creo deployments. But beyond that, everything I spoke to today should be absolutely consistent for you in all of the all of the modern versions of Creo. Relative accuracy. Is it an option? Is it a built-in setup? Very good question. Now, I'm going to close this. Well, we'll just use a file new here, okay? So I'm going to go make a new PRT, and I'm going to uncheck the default template here, and then I'm going to go get one of PTC's templates, okay? Because mine aren't like this, okay? So we're going to go ahead and we're going to say File, Prepare, Model Properties, and that's how we access the accuracy place. Now, when we pull this up on our model properties, this is where we see what the declared accuracy is, and we also see what mode is essentially being used for that accuracy. Now, when we click Change, we see that we have relative and absolute. Now, if you find yourself in a place where you don't get this little pull down and you can't change this to absolute and set a different accuracy for either the current model or your part template, the thing you want to do is, yes, change a config setting that allows that. So on our configuration editor, we're going to go find, as I demonstrated before, and I'm going to type in accuracy. And we're going to go search for everything about accuracy, and we're going to go find that. And when we start looking down through this, you see right here, you know, typical of PTC, you know, I love them, but my gosh, do they put a lot of control on things. So enable absolute accuracy is in fact a thing. So you need to say yes to this because the default is no, unfortunately. You need to say yes to this in your configuration in order to be able to use a fixed, declared, non-changing accuracy. I have a ton of documentation that relates to accuracy, and I, in fact, love sharing it because I wish more people were better educated about accuracy in the PTC world. Anybody that follows up to me via email, and I'll put that on the screen again so you can screenshot it. Anybody requesting Sean's accuracy documentation will receive the copy from me post-haste. So don't hesitate to reach out to me and say, hey, I'd really love to have that accuracy document, Sean, because it has the full 8-page PTC explanation of how all this really works. And it also includes Sean's layman's explanation that is 1 page instead of 8 pages. So anybody wanting for that accuracy document, don't hesitate to reach out to me, and I will bring that to bear. Okay. Sometimes we're having issues of assemblies requiring multiple regenerations. I'm going to close that part here. This is the broken assembly. Now, if you are having to regenerate your assembly multiple times, and when you do, you can come down here in your message bar and you can find this stuff down here, X number of circular references found. It might be more than one, unfortunately. and you're getting a yellow flag or a yellow caution light in previous versions of the system, that's an indication of why you're having to regenerate multiple times for PTC to update everything and get that information square and up to date. The correct way to approach that is most definitely the theory of driver model, or ideally skeleton model, advanced assembly functionality that speaks explicitly to those problems at the end of the day. If you're having to regen something multiple times, it's very likely you've got some CRC gremlins in there, and getting those things sorted out will get things going the way you need them to be working. Okay, is there a way to remember where files are from Creo? When I go retrieve something in Creo and I go find a missing file, is there a way for Creo to remember that? No, there is not. In a literal sense, it's not going to happen that way. Creo's not that kind of SolidWorks-like product because they have to service an arguably much higher clientele. We can't have, a product like Creo going out looking for stuff on the network and just wherever it thinks it might have been. In many networks, those time frames could be enormous to do that. So Creo essentially works with a little bit of something that, and I'll dive in here and kind of show you some from my own directory, as I don't have wind chill. Now, in a wind chill environment, none of this applies. But inside of an environment where we are not using wind chill, the way we tell Creo where things are going to be is our search.pro file. And this allows us to declare directories, as we see here in this example here. I have some NC paths called out as far as that deal goes. And here we have some cutting tool paths. So Creo 6 libraries for cutting tools. This is telling Creo, hey, it's okay to go look in these folders. But just because I browse to a new directory and I select that model, Creo's not remembering that. Creo's going to look for everything in what is the declared working directory. It will then look in the search paths, and then we're done. And if we have wind chill, then it's pulled from the vault. It's a very different concept, but these things aren't such a problem. But in a concept where we're not dealing with wind chill, when we browse to a location for a file, that's got to be on a search path, or Creo's not going to remember that at all in any way, shape, or form. Geom checks and accuracy. Yes, absolutely. Can geometry checks, if we create them, and I don't know that my specific models here have any of them that would be good to show. I don't think this will probably have a geom check, no. But the geom checks are accessed here on the Tools tab. If you have models with geometry checks, they are definitely slowing down your regeneration cycle. Can you be creating these geom checks because the accuracy is not ideal for the work? Absolutely you can. And no pun intended with relation to absolute accuracy there, if you will. But yes, indeed, there is an inextricable link between those things. Accuracy and geometry checks are a thing. At one declared accuracy, something may produce a geometry check, and loosening or tightening that accuracy may in fact eliminate said geometry check because PTC does a better job of solving it under that altered condition. So yes, considering accuracy in the context of geometry checks, very, very, very relevant by all means, most definitely. Something to keep in mind. And a well-timed question I might add to the questioner, because it's arguably something that does have a notable impact on regeneration cycle also. Regeneration cycle is impacted negatively by the presence of geometry checks that are there on any of the models. So make note, I know that's really bad news, but it is what it is. If you've got 3 models inside of your assembly and only 3 inside of an assembly of even thousands of parts, those three models are costing your regen cycle something inside that assembly, because they have that geom check condition that must be dealt with by PTC. During every regeneration cycle, geometry checks are created and or evaluated. So it's absolutely not helpful for them to be present, and dealing with accuracy to see that they don't become a problem for you is a thing. The question is, what's a good accuracy for surfacing operations and surface models? The model doesn't define the accuracy in Sean space. What defines the accuracy in Sean space is the manufacturing requirement, because in most cases when we are talking about surface and or organic shape-based scenarios, we are talking about something where we're very, very likely to be sending that model directly to manufacturing. The implications of accuracy are very significant, because this accuracy value effectively governs the underlying mathematical tessellation of this model. So, the surface on the screen is what it is, but we don't, that isn't physical creation. Physical creation comes from manufacturing, and the manufacturing requirement for that surface and its expectation of quality should drive where this value is. To share in my own personal sense, I come from organic stuff. I'm kind of a plastic, mold, swoopy surface kind of doing work kind of person. My own templates by default are an English temp. So if I create a new component, and I put it on my default part template, as we see here, that's going to come with an absolute 1/10 English accuracy. I do all of my work at that accuracy because it will always satisfy, not because it's mandatory, but because it will always satisfy the necessary manufacturing requirements for the work that I create. And those are arguably more important than the specific number itself, if you will. Okay. If I had to choose between relative or absolute accuracy, and what would I choose, and how critical is it that accuracies are consistent? Okay, I'll speak to the former concurrently with the latter. I do everything in absolute. I am a firm believer in absolute accuracy. What I teach people in an intro class is that if everything you make fits in a 3-foot cube, and you're lucky enough to not have your company buying your computer for Creo from Best Buy, I would say that you should probably be using absolute accuracy, and you're not going to have any problems doing it. Now, if your 3-foot cube has 30,000 components in the assembly, I recognize that might be a stretch with my statement. But in typical assembly space that does not exceed, let's say, a couple thousand parts, and the object is no bigger as a whole than a 3-foot cube, I think most of those folks benefit from being in absolute accuracy. And obviously, I encourage the part templates to be set this way so that we are consistent for all modeling having the same accuracy. Why does that matter? Because assembly-based operations for things like cut, merge, inherit, stuff like that, they require the model on both sides to have the same accuracy. We can't have accuracy of some value A on one part and accuracy of some value B on another part and say we're going to do some kind of cut join operation on these things because, well, which accuracy are we going to use at that point? So the system dictates that we have matched accuracy for most of those types of operations. Using absolute accuracy just makes that real easy, because when we use relative accuracy, as we demonstrated today, I can make a modeling dimensional change that changes the underlying accuracy, because that's how relative works. It's relative to the size of the model. So I'm inherently not a fan of relative accuracy for anything that's not terribly, terribly large. I recognize folks working at places like Caterpillar and John Deere or something like that, where you're building an excavator that's the size of small houses, they probably got to use some relative accuracy, because if that whole excavator was in absolute accuracy, it would probably never regenerate in any of our lifetimes. So it becomes very site specific on how to approach these things. You have to understand the size of your work and what the ultimate requirements are. The power of your computer does come into play, but in my experience, most people are fortunately getting a better computer than what's offered at Best Buy to drive Creo with, and therefore they can handle absolute accuracy nowadays that I would have dreamed about in the beginning of my career. I mean, it was just enormously cumbersome to work with absolute accuracy on Pentium computers back in the day, or any such thing. I mean, things have come a long way, and accuracy can definitely, for most people, I think, be a lot better on the model than what they might do out of the box. Again, be conscious of the manufacturing requirements, because these numbers up here for accuracy on your model and your assembly, that's really who the customer is for that setting. The customer of this setting is manufacturing if you're going to send this model out to be manufactured. If all you provide is print documentation to manufacture your objects, accuracy does not matter beyond how it impacts your regeneration cycle. So hopefully that adds some greater depth to understanding and thinking about how accuracy is not only a part of my regeneration cycle as it relates to time, but how it's a part of modeling here at my work site. Very good questions. I am enormously grateful for everybody that has stuck around and continued to participate and punch out questions to me. I'm going to do a last call for questions now before we wrap up, as we're kind of cruising closer off towards our 1 o'clock threshold here. I'll do a last call for questions that I can hopefully speak to real quick, and then we'll kind of go off and wrap up for the webinar, if you will. I am going to punch my contact and information and stuff back up to the screen while I'm waiting on this last call for questions. And again, I extend an enormous thanks to all of our participants, and especially those that took the time to forward a question, and I'm thanking those questioners on behalf of all participants, because it's likely all participants benefited from all questions. So again, this is last call for questions. If you're thinking about getting one of them in, I would hurry up to do it, because we'll be wrapping up here very shortly. Okay, it's still coming for last call questions here. I'm going to give my computer clock till 12:55. I am currently sitting at 12:53. I'll keep my contact information on the screen for you folks. Unless and of course I get any last minute questions. At 12:53, I will let everybody know we're going to close up the webinar if I don't have any questions between now and then. And again, many, many thanks for all participants and questioners today. Okay, unfortunately, I didn't get any more questions. I am very grateful for the questions I did get today, and obviously for everybody's participation. Again, anybody interested in that accuracy documentation I have, my email's right there on the screen. Don't hesitate to follow up with me. I'll see to it that you get that information. I encourage you to visit the Boundary Systems YouTube channel. There's a short delay period while they process them internally, but typically these webinars are available on our YouTube channel to review again very quickly. So you can go look to see this webinar again from our YouTube channel, as well as get a host of information on a variety of topics, not only model regeneration. So again, I encourage everybody to seek out good intel at the Boundary Systems YouTube channel, to reach out to me personally if I can be more assistance. If you need information about costing or information related to advanced assembly module from PTC, as we did speak to some of that today, don't hesitate to reach out to our sales contact that's here on the screen now. So I thank you very much for everybody's participation today. And with that, we're going to go ahead and close up the webinar. And I look forward to seeing you folks participating again in one of our webinars in the future. And with that, I wish everybody a great day.